Hello everyone. In this video, we are going to talk about object-oriented programming in C#. Object-oriented programming is different from procedural programming because in procedural programming, you write procedures or methods that perform operations on data. But in OOP, it is about creating objects that contain both data and methods. It has several advantages over procedural programming. First of all, it's faster and easier to execute. It provides a clear structure for the programs. It helps to keep the C# code don't repeat yourself and makes the code easier to maintain, modify, and debug. And it makes it possible to create full reusable application with less code and shorter development time, and this is actually life-saving for developers. In procedure-oriented programming, simply we can say C-style programming, the main focus is going to be how to get the task done. And we divide large program into small parts. That means we can divide them into functions or methods. However, in object-oriented programming approach, the main focus is going to be data security. So only objects are permitted to access the entity of a class. We will control the access level of objects. And then in this approach, we divide the entire program into objects rather than methods. For POP, we can say that C, Basic, Fortran, and Pascal are good examples. On the other hand, for OOP, we have C++, Java, C#, Objective-C, Python, and the other new languages. If we want to illustrate the POP and OOP, we can simply say that the left-hand side, it's a POP approach, everything is there, but it's really hard to find them because there will be so many methods, so many variables. On the other hand, on OOP approach, everything is categorized and it is easy to see the problems, easy to see the code, easy to modify it, easy to find it. In POP approach, again, we have global data and then we have functions that containing data or using this data. And then we try to access data or functions through each other. But in OOP approach, we have objects and it contains data and functions. And then these objects can communicate each other. We can share the data through the function of the classes. And that approach, you can control the access of level. You can allow or you can hide your data from other objects so they cannot access, they cannot modify, they cannot change it. And what is an object? Object is a single instance of a class. As we said, it contains data and methods. That methods will work on that data. The good thing is objects are reusable. We can create a class and then someone else can use this class to create its own object. Date, time, audio, video, automobile, people, objects are a good example for this. And we know that almost any noun can be represented as an object in terms of two main things: properties, which could be name, color, and size, and behaviors, such as calculating, moving, communicating. These are tasks. So as we said that the main idea is using OOP, it's much more productive than procedural programming. For the programmers, it is easy to understand, easy to correct, and easy to modify. Let's talk about definition of these terms. Class. Class is it's a blueprint or template, and it contains set of instruction to build a specific type of object. For example, if I want to create an Empire State Building, we need to have building class. That building class define instructions. For example, size, color, length, number of floor, whatever. And based on this data, we can set some variable here and then we can create Empire State Building, and this is going to be an object. Object is a component that contains attributes and behavior needed to make a certain type of data useful. So we'll create Empire State Building from the building class. And if we create one object, it's going to be an instance. If I create another building, like similar to Empire State Building, but this time we can call this different building, and this is going to be another instance. I can create as many as I want from this class. And similarly, dog is a class, and lessee, it's an object, and else it is also instance of a dog class. I can create another lessee, or lessee 1, lessee 2, this is going to be another instance. And then computer is class, then my computer is going to be instance because it's specific type of object. This is another example. Let's say we want to have a car class. We have two main things, attributes, or we can simply say properties, such as model, color, year, price. And we can have behaviors, which are methods, simply start engine, drive, stop, and many more. This car class can be reused many times to building many cars. We can reuse a class many times to building many objects. And this will save our time and effort. So I would like to continue because we are going to create an example. We have two main things in an object, properties, behavior. If an object must have these two main things, that means a class will have this one, properties and behaviors, because object is going to be created from class. So, and the good thing is every car maintains its own attributes. For example, name, it's a property all car must have, but every single car has its own color, its own size, its own name. That will make it unique. So let's create a class simply. And then if we want to create an object, first of all, we have to create a class. And then definition is similar to struct. We have term called class and name of class and curly brackets. And then we first of all define the variables. In other words, we call them properties. For instance, model, year, and color. And later on, we will declare the methods or behavior simply. Start engine, drive, and stop. So to create a class, we first of all, to create an object, we need to write the name of the class. For instance, when we create an integer value, we write integer. Here we have to write car. And then name of your object. It's going to be an instance of the car class. Let's name it car. And then equal new car. This is going to be called later constructor, but for now, let's keep it like this. We'll talk about this later. New means you are allocating a memory for a new object in the RAM. So we create an object. If I want to start the engine, I simply say car.start engine. It will start engine for this specific car object. Let's create some objects using this class. I would like to create a new file called add new class and then call car. Let's add them all simply. Here we have a namespace. We are working in the same namespace, I guess. We will talk about this namespace later. For now, not necessary. So we have class and the name of class. Should be uppercase, and then curly bracket here. Then under this one, we have to first of all write properties, and then behaviors. In other words, methods. In other words, variables. And our variables are string model, which is name of brand, could be brand, integer production year. And then we can have string color. And after that, we'll write the methods here. For example, void start engine. We can put something here, some dummy code, console write line, engine started. And then another method could be void drive. Then console write line drive. And then another one is we can simply copy and paste this one, create another method called stop method. And you can see that the methods and the variables are gray. That means they are not in use yet, because writing a class doesn't mean that they are in use. There's a template. It is going to be used to create objects. So now let's create some object here. I would like to delete this one and just Control C, and I want to remove this main class and go here, simply write method here. I would like to create a car object and say car new car. So now our car object is here. If I say car dot, you can see that we have color, we have drive and model, start engine and stop, and then year. So, and I can say simply drive. If I run the project, you can see that drive. So it's working here. But I need to set the model, year and color. How can I do that? I can simply do this one, car model, and I can say maybe Mercedes, then maybe Mercedes something Z, and I can set the year. It's going to be 2023, and car dot color, this could be black. That's a string value. If I want to print the, for example, year of car, I can simply say console write line car dot year. Everything is maintained in the car object. You see 2023 and drive. So doing this one, we are setting the properties of object. There is a better way to do this one. If you don't want to do this one in C#, we can simply have this kind of thing, and you can set the model and then call Mercedes Z, and then we can set the year. Then we can set the color. Then make it black. So I don't need this one anymore. Then if I run the project, you can see it's still there. It's working. Let's create another example here. I would like to create a rectangle, and then using the rectangle, I would like to compute the area of rectangle and say class, then rectangle. In C#, there must be one single main, otherwise the program doesn't know what is an entry point. I would like to simply Control C and then disable this one. For rectangle class, I want to do the same thing here. Just simply delete them all. And then I will create the rectangle class as Control S, save it. So go here and let's create two things, float width of rectangle and float length of rectangle. And then I would like to compute area, float compute area. In order to compute area, I need to have multiplication of width and length. So what should I do? I should return the width of this object and then length of this object. I can simply say this width, that means width of this object, and then length of this object. If I say this one, it's going to bring me the width, multiplication of width and length, and that will be an area here. So now I have to set the width and length value, therefore I can create them. And then rectangle, so rectangle is equal to new rectangle. Then I can set this value width, for example 10, and then length is going to be 20. Now these two are actually, they are these are global variable. That means within a class, any method can access this data. And then if I give this 10 for width value, the system is going to store, we can make this like this, no problem, totally fine. This is also one way to make things work. If I create this rectangle, and then that means I'm setting this width value to 10. So this is going to be 10, and then length is going to be 20. As long as these objectives exist in the memory, the width and length will be there, and then they will have value of 10 and 20. And then if I call this compute area method, it will take this width value and length value and then multiply them, then give me the return of value. So I can simply say console write line rectangle and compute area method. Now I will have the area of the rectangle. It's 200. Let's see how it's going on. You can put breakpoint here, and maybe can put breakpoint here as well. You don't need for this one. Let's just run project here. Now you see the width is 10, the length is 20, and then if I call this, now the program is stopping here. If I call this method, it's going to set width to 10, length to 20, and return that value, and it's going to be the value of 200, and then it will print it. To better see, you can maybe simply say a float area, and you can simply assign this value to there, and then print out the area. Maybe this will be better to put a breakpoint here as well, and then see here, look at the value of area, and then continue. Now it's 0, it hasn't reflected yet, and then continue. Now it's going to be 200.